Hello and welcome to Physics Teacher. In math, trig identities can be a nightmare for students. But in this tutorial, I'm going to teach you simple steps to take to solve any trig identity in your grade 11 math class. Let's get started. So for grade 11 functions, these are the trig identities you are exposed to. We're going to apply these to prove different trig identities. In this tutorial, we're going to do 5 of them together. Now, the first thing you should always do is pick a side to work with, left side or right side. The side you pick should lean towards being more complicated and have functions other than sine and cosine. So in this case, I'm going to pick the left side. Okay, so the left side we have tan theta times cos theta plus cotan of theta times the sine theta. Now the first thing you're going to do is try to put everything in terms of sine and cosine. So let's get rid of those tans and cosines. So we're going to use this first identity here. So tan theta becomes sine theta over cos theta. And then we still have that cos theta here. And cotan theta is right here. It's going to be cos theta over sine theta. And then times by the sine theta here. So now you can see these cos thetas will cancel. These sine thetas will cancel. And we end up with just sine theta plus cosine theta, which is equal to right side. That's all there is to it. Let's try some more. So the right side in this one looks more complicated, but the left side has functions other than sine or cosine. I'm going to work with the left side of the equation, because that first step is to put everything in terms of sine and cosine. So secant is 1 over cosine. So this leads us to 1 over the cosine squared of theta minus 1. Now, when proving trig identities, you're going to need to use all of your algebra skills. You're going to need to be able to expand, simplify, factor, add and subtract fractions, look at common denominators, all of that. So in this case, you can see we're trying to find something that is a fraction with one common denominator. So let's write this as 2 fractions that we can subtract. So the common denominator is going to be cos squared theta. So instead of 1, I'm going to rewrite this as cos squared theta over cos squared theta. So if I do that, on the numerator, we get 1 minus cos squared theta. But let's look at this last identity right here. If we rearrange this, we can see that sine squared theta is equal to 1 minus cos squared theta. So I'm going to change that whole numerator to sine squared theta. And then on the denominator, we just have cos squared theta. But cos squared theta, using the same identity, we can rearrange that to be equal to 1 minus sine squared theta. So we are left with sine squared theta over 1 minus sine squared theta, which is equal to the right side. How are we doing? Let's do the next one. All right, so which side do we want to work with? The right side has a secant and a tan. Let's work with the right side. So we have cos theta on the numerator. Now let's change these. So secant theta is 1 over cos. And tan theta is sine over cos. Now that's already 2 fractions with a common denominator, so let's just put those together. So we have 1 minus sine theta over cos theta. Now what I can do with a fraction is instead of dividing by a fraction, I can multiply by its reciprocal. So that leaves us with cos theta times, take the reciprocal of this fraction, so we'll have cos theta over 1 minus sine theta. Since this is just a fraction over 1, we can multiply those fractions to give us cos squared theta on the numerator, and on the denominator we have 1 minus sine theta, which is equal to the left side. Not so bad. Let's try some harder ones. This one. Which side do you want to start with? Let's start with the right side. And we'll change anything that's not sine and cosine into sine and cosine. So we have secant, which is 1 over cos theta, times cosecant, which is 1 over sine theta. And then secant again, so 1 over cos theta times cosecant again, 1 over sine theta. Alright, it's looking a little bit messy, but let's just look at the numerator. We have 2 plus 1 over cos theta sine theta. Now if we want to add those, we have to find a common denominator. You can imagine 2 as just being 2 over 1. So the common denominator would be cos theta sine theta. So I would have to change this to 2 cos theta sine theta plus 1 all over cos theta sine theta. And then let's look at the denominator. We have just 1 over cos theta sine theta. It looks pretty messy, but instead of dividing by this fraction, we'll multiply by the inverse. So this leaves us with 2 cos theta sine theta plus 1 over cos theta sine theta, and then multiply by, flip this fraction. So we have cos theta sine theta over 1. Now it's been pretty messy, but now it's going to simplify quite nicely. So those are all going to cancel. And it looks like we're left with 2 cos theta sine theta plus 1. But that's not what we're looking for. But notice that sine theta plus cos theta squared would be a perfect squared. If only we had a perfect square down here. Well, this 1 can be changed into sine squared theta plus cos squared theta. So I can write this as sine squared theta plus cos squared theta, and then put this term here right in the middle. So plus 2 cos theta sine theta. That is a perfect square. And I could factor that as sine theta plus cos theta squared, which is equal to the left side. Okay, like I mentioned, it's important to have all of your algebra skills down pat. All right, one more. You ready? Let's try this one. We're going to work with left side or right side. Let's work with left side because we have a tan here. So left side. We have 1 minus cos squared theta times by 1 minus, this is going to be sine squared theta over cos squared theta. Now, let's remember our trig identities. 1 minus cos squared theta, if we take this identity here and rearrange it, 1 minus cos squared theta is just sine squared theta. And then inside of here, if we want to subtract these fractions, we need a common denominator. So that can be cos squared theta. So we'll have cos squared theta minus sine squared theta, all divided by cos squared theta. All right, now on the right side, we don't have any cosines. So let's change both of these cosines into sines using this identity. We can do that because they're squared. So we have sine squared theta times by this cosquared theta will be equal to 1 minus sine squared theta. And then we have another minus sine squared theta. And in the denominator, we have a cosquared theta, which is just 1 minus sine squared theta. Next, we can simplify that a little bit because we have minus sine squared theta minus sine squared theta. So that's 1 minus 2 sine squared theta, right? Just collecting like terms over 1 minus sine squared theta. Now we can multiply and distribute. So we have sine squared theta minus 2 sine to the 4th theta all over 1 minus sine squared theta. So that equals right side. I hope this helps you solve some trig identities. If you have any questions, let me know in the comments. And if you plan on taking grade 12 physics for a limited time, you can download the whole course pack for how I teach grade 12 physics for free in the description. As always, thanks for watching.